Okay. Thank you everyone for coming back. So I'd like to welcome Jack from Regenesis to talk about his case study. Thank you. Yep.
Still loading? Okay. So it was the tense part, right? There we go. Very good. Hi everyone. So my name is Jack Shaw. I'm from a company called Regenesis, and I'm here today to talk about a case study for planning for flexibility. It's a case study where we look at creating robust remediation designs that can accommodate site reality. So perhaps on sites where things aren't quite as what they appear. So as part of this talk, what I'll give you a brief introduction to us, Regenesis, as well as our client SoilFix, the initial conceptual site model and the remediation expectations, so the goals that were set for the particular site, and then kind of plan A, as it were, so the proposed remediation strategy and then the day one difficulties encountered. I'll then go through the actions that we took to accommodate the site realities and then the subsequent strategy revisions that needed to be deployed, the results, and then a summary and a conclusion. So Regenesis, what we do as a company, we specialize in the research, development, and commercialization of injectable substrates to remediate contaminated groundwater. We also have a subcontracting arm that can come to site and project manage the application of our technologies for you. In this case, we were working for a company called SoilFix. SoilFix are a remediation contractor that provide remediation solutions for the development, industrial, commercial, and public sectors. They've got offices in Bristol and in Essex. So the site itself, the location is confidential. It was for a UK PLC. Had an interesting history. It was a former timber yard and sawmill, and it had a series of underground storage tanks associated with the previous operations. It was remediated in the 1980s for residential and light commercial, and it was during that time that this UK PLC purchased a long lease for this particular site. You can see, yep. You can see here that the area that we were interested in was a car park. Sort of around this site, to the north and east of it, had been remediated in the early 2000s for mixed residential. The driver in this case for the remediation was that the UK PLC was looking to divest this particular site. So a due diligence exercise was carried out and legacy contamination was found. So the initial conceptual site model showed that the site was sands and gravels overlaid by clay. Groundwater was at some 2 meters below ground level. But the contaminant mix was quite interesting. It's something that I come across quite a lot in Scandinavia. So I manage the UK and Scandinavian business district for Regenesis. In Scandinavia, the home of IKEA, they have a lot of wood processing facilities, and this is essentially the contaminant mix you tend to find. So we had some TPH, mostly diesel range petroleum hydrocarbons. We also had pentachlorophenol, or PCP. It's used as a wood preservative, up to 2 milligrams per litre. We then had a series of pesticides, so Deladrin and then Lindane, as well as a series of PAHs. But crucially at this point, no free-phase product had been recorded on the site, and the groundwater direction was reported to be moving from east to west. So the initial site overview then, if you look at the contaminant mix, you've got a bunch of contaminants that, depending on the ambient geochemical conditions, will degrade at a faster rate compared to others. So the petroleum hydrocarbons and the PAHs, you would get good natural attenuation under aerobic conditions, whereas the pesticides would readily degrade under anaerobic conditions. In my experience, pentachlorophenol, despite being a contaminant that would normally preferentially degrade under anaerobic conditions, I have seen cases where enhanced aerobic bioremediation does drive those levels down. A series of site-specific cleanup levels had been derived, and they were quite low. So it was considered that it would be unlikely that they would be achievable for this particular site. So The remediation targets were revised, so there was a DQRA that was completed that confirmed that there was a risk to human health. This risk was largely dealt with through excavation, so sort of outside of the scope as what we provide in Regenesis. Because the ground remediation targets were deemed to be likely unachievable, a revised target for betterment was agreed. Now, betterment for sort of my end of the industry, where we're designing in situ remediation strategies, can sometimes throw up some issues. So betterment broadly can be defined as the improvement of something, and I think it's a really useful mechanism. So it can enable quite a pragmatic approach to the remediation. It can reduce risk of non-compliance, and it can significantly reduce remedial costs. The thing is, it can be jolly difficult to design for. It's quite difficult to work out how much better you want that site to be. Often it can come down to how much money or how much time do you have to remediate the site. I also spend quite a lot of my time talking to contracts lawyers trying to explain what betterment is. So when it comes to procuring these works, you'll typically meet with a contracts lawyer who's saying to you, okay, so what am I paying you to do? And they say, well, you're paying me to make it better. Okay, what targets are we going to hold you to for that? So there's a bit of toing and froing there. So what the agreement was that we would see a 75% reduction in the contaminants of concern, and crucially, this UK PLC wanted to surrender the lease on the site within 6 months post-injection. So the initial remediation strategy we were proposing was a series of excavations across the site to address this human health issue, and then groundwater remediation. So initially, in situ chemical oxidation of predominantly what we were targeting was the TPH and pentachlorophenol using a technology called Regen Ox, which I'll explain in a second. And then we were also going to install a permeable reactive barrier comprising a technology we have called PLUME stop. And then we were going to create an enhanced aerobic system using a technology called ORC, an oxygen releasing compound. In terms of what these technologies are, so I'm going to start to try and talk across a video in a second. I find this very tricky to do, so I apologize if I trip over my words a little bit. Regen Ox is an in situ chemical oxidant that is probably used once every working day across the UK. Is this going to work? No. Okay, so Regen Ox is an in situ chemical oxidant that's probably used once every day within the UK. It comprises two parts. It's a bicarbonate-based chemical oxidant with an iron silicate catalyst that is considered the part B. You mix these two products together with water and then you inject them into the subsurface, and it provides a chemical oxidation reaction that will essentially go on for about a period of 2 to 4 weeks. Now, because chemical oxidation is all about contact, the contaminant and the oxidant must make contact with each other in order for that chemical oxidation reaction to occur. The longevity of that reaction is important, and that's where the extended release comes in. So this presentation is going to be much shorter now the animations aren't working. The second product was PLUME stop. So this is a colloidal activated carbon. What this is, it's a finely milled granular activated carbon that we've milled down to 1 to 2 microns. So that's the size of a bacterium. That's the size of a pore throat. What we have done is we've coated it in a dispersion agent so it moves and behaves like a colloid. So blood is a colloid, wine is a colloid. It flows very freely in the aquifer. When you inject it into the subsurface, it essentially coats the subsurface with an activated carbon amendment that you can then pair with an electron donor or acceptor. So in this case, we used an electron acceptor, the oxygen releasing compound, to create an aerobic environment to degrade the contaminants in situ. The treatment mechanisms for PLUME stop, so you initially inject it and you get a wide distribution of the reagent in situ. You then get rapid contaminant absorption, and because you have introduced, in our case here, We introduced an electron acceptor. You create an environment to grow a large microbial consortia in situ, and this promotes the growth of a biofilm. Now, these microbes that degrade the contaminants in the subsurface, they're not planktonic. They don't swim around in the subsurface, kind of seeking out contamination to eat. They sit on the aquifer matrix and they secrete a biofilm. And it's this job of this biofilm that as the contamination advects and diffuses through the aquifer, that the biofilm catches it so that the microbe can metabolize it. So it often has to wait for its food source to come to it. But with plume stock, you get this contaminant absorption, you get this growth of the biofilm, so you have the microbe and the contaminant hanging out on the same surface, which means that you get accelerated biological degradation. And as those contaminants get degraded, more sites within the activated carbon get freed up, which means they can deal with further influx or back diffusion. And if the ambient geochemical conditions of the aquifer are sufficient, you're getting a sufficient input of electron donors or acceptors, depending on what contaminant you're looking to remediate, you can then get further contaminant absorption, and you can create a self-cleaning Brita filter in the subsurface. Not always, it depends on the ambient geochemical conditions. It might be that you'd have to top that up with an electron donor or acceptor, depending on the particular site. Here, we also had another product, ORC Advanced. This animation isn't going to work either, presumably. Oh, it is. So, ORC Advanced is a calcium oxyhydroxide that we have interpolated a phosphate crystal into this structure. When injected into the subsurface, the ORC will start to dissolve, and as it dissolves, it will release oxygen into the groundwater. Now, these phosphate crystals have an important job. They regulate that release of oxygen, so it provides you with a controlled release of oxygen that can be utilized by the microbes in situ. These phosphate crystals ensure that the oxygen levels within the groundwater don't reach saturation limits, so you get off-gassing. If you're seeing bubbling coming off of your aquifer, it means that you're releasing oxygen that cannot be utilized by the microbes in situ. Then as the calcium oxyhydroxide is degraded, it will form an impermeable rind. Again, those phosphate crystals will keep those pore spaces open, which means that after a single injection of this technology, it will provide a controlled release of oxygen for a period of about 12 months to grow a large microbial consortia in situ, because you're creating a sustained environment, a stable environment over a long period of time. So you grow a large microbial consortia, and you can degrade as much of the contaminant in situ as possible. So, however, on this site, so we had initially planned chemical oxidation followed by plume stop barrier installation, which would then be augmented with ORC. We came across a series of challenges. So we were going to apply the Regen Ox into a series of pre-installed injection wells. At day one, we found that the site was actually far less permeable than we were expecting. So we were seeing significant daylighting at each of the injection points. So daylighting is a term that we use sort of in regenesis and within the remediation industry to describe the product erupting to the surface. So it's not going quite where you want it to do, where you want it to go. So the formation was far less permeable than we expected. And actually, at the day one level, we were concerned that we weren't going to be able to get a sufficient volume of plume stop in around the edge of the site for the treatment to be effective. So we had to think on our feet a little bit. So we first had to find out, why is the Regen Ox daylighting? Is this because it's reacting with more contaminants that are in situ than was expected? Or is it because it is less permeable than we expected and we just can't get the volumes in? So we altered the dosing to see if we could minimize reactivity. That didn't seem to make much of a difference. We then did a series of clean water injection tests to assess the volume. And we also were able to then review 30 additional installed wells across the site to see if the conditions were as expected. And actually what we found was that it was a permeability issue. We couldn't get the volumes in that we were hoping. The additional driller's log showed that the site actually had a much thinner band of gravels than initially expected. So what we then had to do is undertake a very quick supplementary site investigation. So we did a window sampling exercise across the site. And we also mobilized an MIP rig to site, so a MIP rig, to better characterize where the flux zones were on the site. And I can't stress this enough, particularly if you're considering an in situ remediation strategy. It's not something that I see done very often here in the UK, but the data that you can gather from these from this site investigation method, for us is invaluable, and it can help us deliver a much more targeted strategy than you can with, say, other conventional or more commonly used site investigation methods. We also did a series of clean water injection tests to assess what volume could be accepted on the ground. And then we reviewed our proposed remediation strategy. So our conclusions were initially that the groundwater was actually moving in a slightly different way. After we had installed all of these injection wells, we had a much higher resolution than we did previously. So it was actually moving towards the north. This continuous gravel band that was reported was actually much thinner than expected, and that then had an impact on how we would undertake the works. But crucially, what we found was that we were still getting the radius of influence that we needed from each of the injection points. So we had a change of strategy, so there was some flexibility in what we could apply. So we used Regen Ox within this central corridor of the site. The reason for that is that there was a series of underground cables that were there, and when you inject Regen Ox, which is a bicarbonate-based chemical oxidant, it won't impact any underground infrastructure. We then used another reagent called persulfox, which you can dissolve a much higher concentration of the oxidant into that volume, and you're not seeing, and it means that you can minimize any daylighting. We also changed how we were going to then use the plume stop, so we altered our injection configuration. So instead of a barrier application, we still could utilize plume stop, but we chose to do it in a targeted grid formation, in a grid formation across the site. And then we did targeted doses of ORC advanced in areas where we had particularly high levels of contaminants that would degrade under aerobic conditions. In all, these injection works took about 4 weeks on site, spaced over a period of 6 months. In terms of our results, so this is the average dissolve phase TPH across the site. The chemical oxidation phase, its job was to reduce the contaminant mass to levels where plume stop absorption and bioremediation would be effective, and we were able to reduce the TPH levels to close to below detection limit. Similar results with the pentachlorophenol, so the chemical oxidation phase reduced that, then the plume stop kept those levels below detection across this treatment area. Average pesticide concentrations, again, reduced to quite close to below detection limit. You can see we've got some noise here, but we are at 5 micrograms per litre, and again, we saw some success using plume stop. In terms of the results of this site, so in all we saw about a 96.3% reduction in contaminant mass, and what you will notice is that the average concentrations post-remediation for the most part hit those site-specific action levels that were considered not achievable sort of prior to our involvement. So in conclusion, the additional investigation costs did increase the cost of the project by about 4%, but we were able to turn this around very quickly and be quite reactive. There was no changes in either cost or program for the remediation works for our element of the works. I think it's really important just to, don't be afraid to stop, investigate and act, and sort of allow this for within your remediation approach. Always have some kind of flexibility built in when you're doing in situ works. And really communication is key. especially with your friendly remediation technology provider. You know, if things aren't quite going as expected, do let us know, and often there are things that we can do to react to those site conditions. And that's everything. So thank you very much.
Sorry, I'm not going to get away that lightly. Anybody got questions for Jack? Oh.
Given that a lot of the effectiveness of it is reliant on the microbial activity, did you first do an investigation to find out what was down there, like use biotraps and things like that?
So, in my experience, the microbes are already there. They just need a kick to start the degradation process. So, unless, typically no, in the UK, we wouldn't look for that. Now, in parts of Finland, sorry to go into that, but in parts of Finland, or if you have a site where, so you've had a chlorinated solvents are easy to talk about. So if you've had a site where you've had a PCE spill and you're not seeing any signs of dechlorination at all on the site, then that's the time that I would start looking for microbes in situ. Or if there was a really unusual specialized contaminant that would only be degraded by a certain group of microbes, then it might be worth looking for. But for things like the pesticides that were here and petroleum hydrocarbons in particular, often all you need to do is just create the right environment to degrade them in situ. What we find.
You've never had to actually introduce them?
So chlorinated solvents, if you are dealing with a mix of chlorinated ethenes and ethanes, there is some merit in introducing an inoculum of dihalococoides that will preferentially degrade chlorinated ethanes, just because often what you see if you just add a donor is that you'll get good degradation of the chlorinated ethene, so TCE to DCE to vinyl chloride and through to ethene. But sometimes you can see things like TCA and DCA stool, so adding an inoculum to try and degrade that is what we would recommend.
Brilliant, thank you.
Any other questions? Okay, thank you very much.
Thank you.
Okay, excuse the technology, but we're doing a tag team CliffNet presentation. So we'll be doing, there's a lot of presentations to get through. Right, let me open all of them up. I can't remember which ones I've opened, I haven't, so I'll open them all up. Oh, sorry. Right, pre-planning. I think we're starting here. Is that right? No.
The first one is the pre-planning one.
That one. Cool.
Cool, that's the one, yeah.
Yeah. Like introducing Hannah to set the scene.
Sorry. It's not appeared yet. Whilst it's waiting to appear, so the Contaminated Land Forum kind of a steering group, we got together kind of November and talked about what presentations we'd like to see in this workshop and what we'd like to discuss. And one of the themes that came up was actually the common pitfalls when sites are taken through that planning process. And so what we decided might be interesting and useful, and hopefully will invite quite a lot of discussion, is a tag team of slides about what we expect to see, kind of an ideal scenario for quite a tricky site throughout the planning process, consultant view, kind of regulator view, a bit of a mismatch. And hopefully there'll be lots of interesting questions afterwards, obviously once we've all kind of got through our slides. So I'm kind of providing the consultant view on a couple of topics. Here is our example site, roughly thrown together by someone from my graphics team a couple of days ago, so I'm not quite sure what happens to the groundwater as it goes off site. It's a little bit of a dramatic drop, but you know, let's just use it as as a guide for now. So our site, theoretical site we're going to consider is, you know, industrial site, factory site, with an R&D department, some tricky contaminants, unusual contaminants on chalk, maybe with a bit of make ground, maybe with a bit of gravel below, but fairly shallow water table. It's an SPZ1, public water obstruction borehole beyond a river. There is a river. We've also got some residential housing right adjacent to the site. So we've got lots of receptors there to think about. We've got, you know, very sensitive groundwater body. The proposed development is not shown in this plan, but it's going to be a residential development. Now, just so we can all imagine what it's going to look like, let's imagine it's got a mixture of low-rise housing and maybe some high buildings that are going to require a bit of piling. There's going to be some landscaping, some private gardens, so you've got the topsoil considerations. So, in an ideal scenario, when would be a good time to involve a consultant? Well, my view is, before any big decisions are made on the site, seek to get advice from a specialist. So before kind of a big investment is made, before acquisition, in order to be making those kind of basic decisions about a site, I think, or preliminary decisions about a site, I think it's important to have a basic understanding of the ground contamination. I think it's also important, if someone's buying a site, to arrange an independent review. Don't just rely on vendor reports. A couple of years ago, I saw a great site, not in this patch, where a developer had bought it, acquired the site, and they'd relied on the vendor report, which stated, it was a petrol filling station on chalk, by the way, stated, the site will be low risk, is considered to be low risk, once it's been remediated. So yeah, that wasn't a lie. The site hadn't been remediated, it was a filling station on chalk with NAPL. And so it was not at that time low risk, but the developer ended up kind of buying a little bit of a turkey on that one. So why is it important? Well, ground contamination, obviously, you know, probably teaching you how to suck eggs here, can affect development costs. It can affect, do you need to install vapour membranes? Have you got huge amounts of soil to remove that's going to, you know, it's contaminated, it's going to up waste costs? It can affect development timescales. Not all remediation is a quick dig and dump exercise. And often it is more cost effective to think about a longer term approach, such as your bioremediations, rather than, we've only got a certain amount of time to do it, we're just going to have to dig it out. It can actually affect overall development feasibility. Once you consider the cost timescales to deal with the contamination, actually, is this going to be a profitable development? Note to the petrol filling station on chalk example. And then, you know, there's also, it's not all negative, there can often be opportunities. So, for example, if you know that there's going to be a basement somewhere on site and you know you want to dig out a large hotspot of contamination, or that's one of the options being considered, you may as well put the basement where the area you need to dig out is. Or similarly, if you've got a problem area, maybe put the parking there, car parking there, rather than the low-rise residential housing. It's important to make sure the assessments are joined up with other assessments, drainage, etc. The competencies was obviously discussed quite earlier. So I think that's an important one to consider. We don't actually see very much demand from this from a consultancy point of view. I had a quick run around the company, ring round for today to see what people thought about, what people's experience were of this. And actually, we almost never ask for it. I think it's interesting to, it's an interesting perspective there. And I think it's something that actually, if there was more of a commercial drive for it, i.e. we were being kind of pushed for it through clients or regulators pushing clients for it, I think there'd be probably more of a push from consultants to make sure there were more people with external accreditations. So I'm going to just try and rattle through this because we've got lots of slides. A preliminary risk assessment, that's, in my view, kind of what you really ought to be doing is an absolute minimum before a planning application goes in. Although if you've got a tricky site, think factory on chalk with lots of contaminants and sensitive receptors, it's common sense, in my view, to do some kind of initial investigation at the least before you take it forward to understand what could be there. The preliminary risk assessment should include a site visit. It's important to understand what's on the site now, what's might have happened in the last few years, not just what the last historical map from 10, 15 years ago shows. One of the things that came up when I was looking for views on this from both a regulator point of view and other consultants, the PRA must include a CSM. Now, a lot of phase 1 reviews do not include a CSM. There are reasons for that. A lot of phase 1 reviews are just done for, someone's acquiring a site as part of an investment portfolio. They don't want to spend, an extra couple of £100 someone developing a CSM. They just want to know low, medium or high risk. And so that is a product that consultants deliver for a separate purpose. But that is not what should be submitted for planning. So CSM is important. Consider, both make sure you consider the proposed use of development properly. Are there new sources being introduced? Think about drainage, generator, tanks, that type of thing. Really make sure the off-site receptors are considered. Off-site residents are one that is often forgotten from what we see. Once you understand and you've developed a good CSM, then and you've got those pollutant linkages, those can be tracked, and then should be tracked throughout subsequent phases. So has your site investigation considered those linkages? Has your remediation strategy considered those linkages? And then ultimately, have you validated that the risk has been appropriately mitigated? Another piece of common feedback, a pictorial or image of a CSM is so much more useful than just a table. The tables are often repetitive, often a bit of a copy and paste exercise. So initial site investigation. Like I say, I know not everyone does this before a planning application, but for a difficult site, I think it's really important to do. Once again, refer back to that CSM. We're supposed to be tracking those linkages, sources, pathways and receptors. Make sure, this is a common bugbear of mine, that any unusual contaminants are considered. So we mentioned that our imaginary factory has got an R&D department. Well, make sure you understand what contaminants have been used and they're tested for. Are VOCs unusual? I don't think they are that unusual. Many industrial sites have used chlorinated solvents. The amount of investigation reports I get asked to, third-party ones that I get asked to review, that have got a standard suite for metals, PAH and EPH on a print works, for example, is ridiculous. So VOCs, in my view, are pretty common contaminant and should be included on most sites in at least some of the analysis suites. Think about borehole spacing. Often for more difficult sites, there is an initial investigation and then the subsequent stages of delineation, maybe post-demolition investigation. So, maybe you're not going to achieve ideal final borehole spacing at this stage, but think about making sure you've got correct coverage. There's obviously the, considerations for all investigations. If you're drilling into a chalk aquifer or any sensitive aquifer, just, think about environmental drilling, clean drilling methods, aquifer protection. Make sure you're targeting the correct groundwater bodies. Our site's a little bit more straightforward. It's got gravel and chalk, and the groundwater was only showing in the chalk. But the amount of sites I look at, or site investigations I look at, where someone's forgotten to see if there's any perched water in the main ground, for example. Also think about making sure your wells are appropriate. So just the usual stuff. Is it a gas well? Is it a groundwater well? Is it intended for both? What are the limitations? How many rounds is appropriate to do before you submit to planning? If you've got a sensitive groundwater body, in my view, it's useful to have a couple of rounds. Ideally, show seasonal changes. You might not be able to have time to do that before planning. Ground gas monitoring. The guidance actually requires quite a lot of monitoring for ground gas. But if there's going to be substantial groundwork to the development, maybe it's better to just do something initial up front and shove the rest down the line. In an ideal scenario, discuss with the regulators. And once again, I have sought kind of, input, feedback from colleagues about this. And one of the big kind of frustrations, challenges that's often been described is actually just not being able to discuss with have regulators and have that face time. So I think that's something that's an ideal scenario, but not always achievable. Final slide for me is generic risk assessment. Obviously, if you're doing a pre-planning investigation, you have to take it to at least an initial investigation stage. Few bugbears from me. Shouldn't replace investigation findings. The amount of times I see in a report, there was no exceedance of the GACs. Well, that's nice, but were there any shocking concentrations of anything that actually are of note, particularly with regards, other receptors that maybe the GACs don't properly consider? Stative NAPL's been observed. Often that's not stated. Make sure the GACs you're using are appropriate. There's a huge kind of a variety of published standards that can be used. A lot of companies have in-house GACs as well as the published standards. But make sure you're using a suitable standard. Ensure human health risks from groundwater are considered, volatilisation. And don't forget the gas assessment. And make sure you consider whether soil vapour is a real consideration. So I rattled through that as quickly as I could, and I probably skipped bits, so I'll hand over.
Cool. Thank you. Okay, so the scenario is now you've prepared your application documents for planning, and it goes off to the local planning authority, who then consult the Environment Agency as well as other appropriate bodies. So just a reminder what the Environment Agency policy on prioritisation is. So we still have GP3, we call it GP3 by acronym, but it's actually the approach to groundwater protection. That's still on the .gov website. Our prioritisation policy came out in 2008, which we're still using, which helps the groundwater and land quality teams decide when we're going to provide bespoke, in-depth advice. There's a link to GP3. There's a whole host of groundwater position statements in there, which talk about the NQMS, DOWCOP, how we expect developers and other operators to ensure that they're complying with legislation and all the regular guidance. So land contamination and planning is a huge amount of work for the groundwater and land quality teams. Back in the day, the Environment Agency decided not to be a statutory consultee where the only constraint is historical contamination on a site. So we provide advice to the local authority, to consultants on development proposals on these sites, and we provide advice to them to help them decide whether or not to discharge a condition. We do not discharge conditions, it's the LPA who does that. So that's just a reminder. Also, our other sort of involvement in sites tends to be from environmental permitting as well. So 9 times out of 10, if you're doing a quite detailed remediation strategy on site, there'll be some kind of environmental permit involved, being a mobile plant deployment, maybe because it's the actual remediation is taking longer than a year. It might actually need a fixed site permit as opposed to a mobile plant permit, but we can talk about that a bit later. I just brought out a list of what we are actually statutory consultees for. So Schedule 4 from the Town and Country Planning regulation in 2015 lists out the actual sort of duties of the Environment Agency, if you like. So that's the whole of the Environment Agency and not just the groundwater and land quality teams, okay? So we do get involved in developments involving mining operations, not so much in Herts and North London, but other parts of our England we do. Obviously the developments next to 20 metres of tops of riverbanks. We also have environmental permits for those as well, so that's like a dual consultation in some respects. So development for the purposes of refining or storing mineral oils or derivatives. So petrol filling stations fall into this category. So if you're proposing a brand new petrol filling station, tends to be, I have to say, supermarkets more than the big companies these days. Obviously, one of the things to draw attention to in the approach to groundwater protection is that we will normally object to a brand new petrol filling station in SPZ1. Especially if it's within 30 metres of the obstruction borehole. We also consulting for cemeteries, that's brand new cemeteries as well as extensions. And then ZB is for coma sites, so the likes of Buntsfield, where they store huge amounts of fuel oil and that type of thing. Because the Environment Agency, a joint regulator with HSC, we are also consulted there as well. ZC is to do with flooding, and ZD is major developments which do not use the services of sewage undertakers for the disposal of sewage. So there are places in our patch which can't connect to a foul sewer, and they need to either do discharges to ground or have their own sewage treatment works, as it were. So in those cases, the Environment Agency would be expected to be consulted. If it's a discharge to ground, then the groundwater and land quality teams would definitely be consulted and provide further advice. Just a reminder, what C11 looked like. Sorry. Okay, so coming back to, we've got a planning application. It's coming to Herts and North London team. It's hit our matrix. We're interested. We're going to put planning conditions on. What sort of conditions do we put on? We put on all of those, usually, 9 times out of 10. So there's the, so I think it was back in 2008, the planning inspector wrote some standard conditions for land contamination. They look very similar to our 4-part condition, but I think some local authorities still use the standard condition that the planning inspector wrote, and some of them make their own version of it. So it's very difficult sometimes when we get consulted for discharge conditions a bit later. They always refer to, the land contamination condition. You always have to go back to the decision notice and look at the actual wording of what's being asked for, because you can't always assume it's the EA1 or like the PI standard one that they wrote in 2008. If we've asked for a 4-part condition, then we will always ask for a verification report. If it's if there is contamination and it's groundwater contamination, we'll ask for long-term monitoring as well. Sometimes that means that you can actually discharge verification report and sell, I guess, mortgage issues and stuff. The verification report condition can be discharged, but if the remediation strategy means that long-term monitoring needs to occur, say, for instance, you've used in situ chemical oxidation and it's going to go on for some time, especially for in situ anaerobic degradation PCs and all that sort of stuff, will always take longer than 1 year to sort out on a site, so we'll always ask for long-term monitoring. However, there is an option here that you can ask for, instead of a long-term monitoring condition, you can have it put into a Section 106 agreement with the local planning authority instead, which means you don't have a discharge of condition on the planning decision notice, but it is part of the Section 106, which is slightly, I guess some companies or some developers may prefer that route. It's an option. Obviously, unsuspected contamination. We also have a infiltration sud. So if we have that is affected by contamination, we don't really want to see preferential pathways such as borehole soakways being put on site. Piling and foundation risk assessments, and the newer one is the decommissioning of investigative boreholes. So in the past, we would have looked for like a borehole management strategy sort of tied up with the groundwater monitoring programme, either as part of the 4-part condition or as part of the long-term monitoring condition, but that's now a separate condition all on its own. I'm not going to read out the 4-part condition. Most of you know what it looks like. So we asked for a PRA, a site investigation, a DQRA, options appraisal, remedial strategy and verification plan. So 9 times out of 10, we'll do a partial discharge of condition. If we've asked for if you've supplied a PRA in the planning application, but we feel that there's still bits missing, we will normally use all 4 parts of that 4-part condition. However, if we've been involved substantially in, say, pre-app discussions, then sometimes we can not use that first part because we've agreed the preliminary risk assessment part and the CSM, and we just take forward parts 2, 3 and 4 later. A note here is that, referring back to the techno-finish case up in Leeds, the planning inspector said that the planning authority, be it for the land contamination part of it, be it the contaminated land officer or the EA, are well within their rights to ask for all of those reports associated with 4-part condition, or up to verification report if need be, for a site before planning is granted. But in the way that we want to facilitate development, we kind of feel that if there's enough information provided at the application stage, then we can actually apply the condition, because we feel that we can get that data later rather than making you not even get planning consent in the first place. Just a quick reminder there about MPPF is that if a site has been remediated, we don't want to come back to look at it under Part 2A later. And there is a section there about adequate site investigation must be prepared by a competent person, and in the planning guidance a bit later on it defines that competent person is usually somebody who's chartered or similar with experience. So just slight pointers with the DQRA. The first point of call is for a compliance point in a DQRA for controlled waters is that for hazardous substances, the default compliance point is 50 metres for both principal and secondary aquifers. And obviously, if you've got groundwater in the secondary or the superficial deposits above the principal aquifer that are in direct continuity, we'll adopt the overall designation of principal aquifer in those cases. Small observation and slight bugbear is don't really want to be seeing a Tier 4 DQRA if your Tier 3 is just based on lit data. I actually want to see site-specific data and a whole load of supporting info before we even discuss Tier 4. Okay. Also, the other observations that we've had are that if you've done your DQRA based on a conceptual site model with a compliance point of 50 metres, that's like the numerical model for the DQRA. If you feel that you need to, you can't achieve that, but actually if you go on to do modelling with 75 metres or 100 metres, and actually things are slightly more achievable that way because they're better in the ballpark, as it were. So for instance, no, I'm not going to give that info. Forget that. Scrap that. There is, when you go into the land contamination and the risk assessment guidance bit on the .gov website, there is a scenario there that you can talk about providing a sustainability assessment, cost-benefit analysis, not just a cost analysis. So, if I remediate to 50, it's going to cost me 10 million, but actually if I remediate to 100, it's going to cost me 2, so I want to do the 2. No, that's a cost analysis, not a cost-benefit analysis. So the Surf UK is there to help you with sustainability assessments. And also for verification plan, we would expect to see detailed groundwater monitoring programme, ideally monthly, during, and for a good 12 months after the intrusive groundworks are finished as well. I said we always ask for a verification report. Ideally, if you've done specific techniques, we'd like you to refer back to our verification guidance. So when it comes to the long-term monitoring for groundwater monitoring, I like to partially discharge this one. So you submit a detailed groundwater monitoring plan and programme, scheme of works. That goes to, so it's the telling us what you're going to do, and then you actually submit that first, and then after we've agreed and you don't need to do any more monitoring, that's when we'd expect to discharge it fully. Previously, I'd unidentified contamination because no intrusive site investigation gets everything the first go. It's a really iterative process, refining and refining a conceptual site model. And there are cases where, you know, somebody's buried a drum where you didn't expect it to, or a whole load of asbestos or whatever. So, you know, that's always there to capture all too. With respect to SUDs, sometimes we see land contamination remediation strategies not tied up with the drainage strategies, and we get cases where people want to do soak away to ground for roads. So our guidance in the approach to groundwater protection says that you can do clean roof drainage water to ground without a permit. Anything else, you should really come and talk to us, because road drainage does have hazardous substances in, and we don't really want to see those. We've got a duty to prevent those from reaching groundwater. Piling, especially in SPZ1, it's come to our attention not only in Herts, North London, in our Solent South Downs area. The water companies are very concerned about people doing intrusive investigations close to their abstraction boreholes. So whilst the installation of the borehole itself may introduce turbidity, so turbidity itself is not a pollution contaminant of concern. However, if the suspended particles do have hazardous substances or non-hazardous substances absorbed on them, then that could cause pollution. So it's not that we've suddenly been stricter on what we expect to see for mitigation or piling risk assessments and stuff. We're just taking it, I won't say we're getting stricter, I'd just say we're taking more of an interest, if that makes sense. And if it's very close, then speak to the water company, because they may require you to put more specific requirements to augment your mitigation measures. And then, again, for the decommissioning investigative boreholes, we expect to see a detailed decommissioning plan. Don't really want to see a discharge of condition here just based on a one statement saying, we're just going to do what the agency guidance says, because that's what we've had, and it's not really good enough. We actually want you to think about what you're actually doing. So if there's a site that's been peppered with boreholes, then we want you to make sure that you've gone round and actually identified where they all are and decommissioned those properly before you start piling and things like that. Just a note, if planning consent is granted, we normally, it's based on the information at that time, but we've seen cases where we've agreed remedial strategy with one consultant, and then there's a change. Somebody else has bought the site and they've brought a different consultant on board. If there's a change to the remedial strategy that's already been agreed and discharged, then technically we need to see the resubmission, especially if the remedial strategy has changed or there's new information and the conceptual site model has changed as well. Okay, that's me done. Linka is next. Sorry, I've got to find it. There we go.
Okay, I'm Olayinka Kandeo from Brent Council. I'm an environmental monitoring officer. I'm just going to go through briefly, because I know we're running out of time here, about what we would expect as a local planning authority. So we've heard it mentioned quite a few times, the NPPF, just a list of what the planning decision should cover with respect to land contamination. Next slide is example of the type of condition that we would put on at Brent. So I know that it's going to be different for each different local authority. when I say different, I'm talking about the wording, but we're all trying to cover the same thing. Okay. Yeah, I've got it. Just use the... Oh. So I just need to... Yeah.
You could use page down, I think. Should
Okay.
work.
Okay, so, yeah, so at Brent, we generally use, we've got two main conditions. So the first one is the investigation one. And so that, I think, as you can see, it covers quite a few things. When we get to I think the last bit is the remediation options. So it's only until we've got all of that information would we recommend to the planning department that I would be able to discharge that condition. And then the second one, that covers the remediation verification. So it's only till we get to the end, so we get the verification reporting, would recommend it for discharge. And also, just a point is that once we've got the remediation measures, I would be checking back to the original report to look at the recommendations, just to make sure that that everything's been covered, and then also do another check between the remediation and the verification. So we're constantly checking that everything that we've asked for has been covered. Okay, so how are we assessing the risk? We're looking at the conceptual site model. That should be referred to through every process. So if there's a PRA on a site that's quite complicated, like the model site that we're looking at, that we're discussing today, it's quite common that we probably would get a PRA, a desk study at the pre-planning stage, or and that would often be in communication with the consultant or the planning consultants, just to agree the way forward, what we're looking for. Okay, so conceptual site model, that's what we're looking for. Generic GAC. We've kind of discussed that quite a lot today. If there's, and of course, this site's, the model site that we're looking at is quite complicated, so it's more than likely that we'd expect to also see a DQRA as well. Okay. Okay. Oop. I've gone too far. Okay, so remediation works following the risk assessment. So this is also part of our, so this would be still part of our condition 1 that we were looking for the report to cover. So just put it there. And also, so there's further details on the validation of remediation works. I'm not going to read that out for you. Another thing that we also include, it's not necessary, that we're also looking for, is to consider statutory nuisance and development. So a site like our model site is going to be affecting the neighbours, and so we'd often, that's often going to be another condition as well. It's not going to come under the contaminated land conditions, but that's another thing to sort of think about. And often people do include it in their reports as well. Okay, and yeah, so if we do have problems, it's dealt with under statutory nuisance, and that can obviously cause a delay in in the whole development process. So that's me telling me to stop. Okay, so that's just give you a little insight into what we're looking for as a local planning authority.
Matt. Okay, which one's first?
Good question.
Is it tag team? Is it that one?
Yep.
Okay.
That's the one.
Yeah,
It'll do.
okay. Sorry, introduce yourself.
Yeah, hi. While we're booting up, I'm Matt Leonard, Senior Geoenvironmental Person from the NHBC. I cover, for those of you who don't know, probably most of you, East Anglia, all the way down to North London, so this is probably pretty much my patch. So, yeah, so this is just very, very quick, just to remind you that other than keeping the environment agency happy and the local council happy, if you're building houses on the site, there's a reasonable chance you'll need to keep us happy too. So just a quick recap, we're not a regulator. I said that when I was interviewed for the job, and I got told we're definitely not a regulator, we're an insurer, but we kind of regulate because we want to protect A, our warranty, and B, make sure that and protect the homeowner. So under our standard building warranty, that's the new one, contaminated land is covered under section 3.6, and it will cover, if you have an issue, work required to improve the condition of your land, if you receive a statutory notice, or if your statutory notice could be issued because of the condition of your land. We're kind of looking at, we're talking sort of Part 2A sort of level really, but we do also provide building control, and in those situations we're potentially looking at more sort of planning-based mineral risk approach. So how do we manage that? We use our NHBC standards. Chapter 4.1 is the land quality bit. We want to ensure that our sites are properly assessed and investigated for all contamination hazards, plus the geotechnical stuff. Foundations and substructures are suitable for the ground conditions, so that will include ground gases, contamination. We want to see that the sites are properly remediated when necessary, and all appropriate design precautions, whether that's clean cover in the gardens, again, gas protection measures are taken. And we will need to see documentation and verification that all that work's been done properly, and everyone could be happy. So basically, it's very similar information to what everyone will give to the councils or the environment agency, but there's a few differences. So if we don't always align, that's probably why. And there you go, that's just a nice picture of our standards and our little flow chart, which is a little bit like CLR 11, but not quite. And then, so in terms of our geoenvironmental processes, every site that gets registered with the NHBC, we get a landmark report basically. So we'll do a quick check ourselves. If it's flagged as greenfield, we might go, greenfield, don't really care, it's not an issue. If it comes back as possibly contaminated, we're going to start asking questions and setting mandatory conditions, which could be something as simple as a death study, if we're not sure, could be site investigations, and then if that leads on, depending on the findings of those, that will lead on to remediation strategies, then details of the designs, and ultimately the verification reports. So we want to see everything. Although we might only get involved towards the end when the house is being built, we want to know that those sites are clean before we start putting houses on, and make sure that we understand all the risks, and if we're going to put in gas protection measures, they're appropriate and suitable, and similarly with if we're going to start worrying about clean cover for that in people's gardens, that's appropriate and suitable as well. So, and ultimately, I guess the stick we'll use to hit the house builders with is, if you don't give us all this information and we're not happy, and we still leave conditions there, well, you don't get a warranty, which means the house buyers don't get a mortgage, which means no sale. So that's ultimately sort of where we come in, really. So, yeah, that's it from me.
David, next.
Thank you. I'm David Dyson from ACOM. I've got 5 minutes to talk about discharging pre-commencement conditions, which isn't a great deal of time. Luckily, there's a lot of crossover to what people have already talked about, so I'm going to kind of probably just give my view of where a lot of the problems lie in the industry sometimes, and the best ways to try and avoid them. So just a very quick reminder of the kind of pre-commencement conditions, very generally, desk study, preliminary risk assessment, as Hannah said, often done pre-planning, site investigation and risk assessment, kind of lumped in together in the conditions sometimes, and then remediation strategy, including options appraisal and verification plan. And they may all be pre-commencement conditions. And then obviously with the site that Hannah talked about, there may be other more specific conditions, infiltration, piling, deep borehole decommissioning. But what I want to kind of get across is, although I'm talking about pre-commencement conditions, actually a consultant's role should be always with an eye on the preoccupation condition, because that's where the developer wants to get to in the end. He wants that validation, he wants a good validation report on the regulators table right first time. So it's very well getting through the pre-commencement conditions, but they're not the final objective really, and consultants have to try and maintain that focus. There are problems with that, which I'll mention. So the first bits have sort of already been covered, or certainly the if assessments, pre-planning assessments have been done for purposes like land transactions, they may not be sufficient. You need time to review, maybe put it in the right format with a proper preliminary risk assessment, looking at the right linkages. We may have, the early stages might have been done by non-contaminated land specialists, so again it needs a review by a specialist, qualified people, because it may have been done by the structural engineers or geotechnical engineers, looking at constructability and feasibility. One problem is that different stages are sometimes seen as separable, or they end up being separated in the development process. I've kind of called that separation problems here. There are a lot of good reasons for that. It might be procurement rules within a developer's organisation, a hiatus in the development time frame because of funding issues, and so you'll have a site investigation done, and then a few years later it'll come back and someone else is asked to look at a risk assessment for it, and then maybe separately you jump on to a remediation strategy further down the line. Oops. I'm going the wrong way. What have I done there? Oh, the wrong way. Right. Whoops. Sorry. They all look the same. These slides are not the best. So yeah, the disconnect, and then looking further forwards, the same thing, the disconnect you can get between a consultant produces a remediation strategy to get through that pre-commencement condition, and then who's delivering that? It may be a contractor, hopefully a specialist remediation contractor, not necessarily always, and that could be driven again by procurement strategies, funding and timescales, leading to disjointed delivery, and that's something, a challenge we have to get past. So how do we do it? Very quickly, I won't really dwell on this, but again, going back to the land contamination risk management guidance, is now out imminently replacing CLR 11, which is being withdrawn very shortly. But it goes through all the key steps: preliminary risk assessment, that's risk assessment, as in site investigation, risk assessment, RA, options appraisal, remediation strategy, and you know, there's a lot of good things in the guidance. Some key things: it uses the word must a lot. It's quite prescriptive. There are some good checklists. It kind of tells you a lot of the things you need to do and include to go through this process well. It isn't published yet. I think this was mentioned before. The options appraisal matrix has been taken down again, but it's going to go back up at some point this year, because there is a focus on competency, definitely, the kind of things Hugh was talking about, and NQMS. The word must doesn't extend to NQMS. That's still an option, but there is a lot of a lot of requirements in there, and sustainability is certainly a focus. Cost benefit, as Teresa mentioned, you have to have that benefit element as well, and sustainability is one way to look at that. The one thing that you don't have quite so much compared to CLR 11 is there's no longer the separate implementation of remediation. So the implementation plan is kind of wrapped up in the remediation strategy, and that's something for consultants to make sure that they've got enough detail in there for it to be handed over, if that's how it works, to a contractor delivering it. So detailed review, I'm aware I'm behind my time, so I won't go into this really, but it's about having the time in your development programme to identify the data gaps as these stages progress, possibly with different people doing them. Looking at the development plans, filling the data gaps based on your historic site layout, and now you've got your development plans for your planning application. Other conditions, this is really important for other disciplines, ecology, environmental monitoring needs to come into it, air quality monitoring, noise, vibration. There may well be conditions on that. You need to read your conditions, all conditions, not just your contaminated land conditions, to understand what you need to do. An initial feel and prioritisation of high risk links. Some remediation can take time, and so some requires quite specialist input. Some can be expensive, obviously, and disruptive. And there can be complex input to engineering design for some remediation solutions. So again, the other disciplines need to know about that. So update to PRA, non-standard. So looking at a complicated site, you might have a basic desk study. You need to think about non-standard linkages as well here. And when I say non-standard, I mean the things that aren't automatically maybe referred to in the clear modelling. Contact with surface water, is the river being brought in as some kind of recreational use? Teresa's mentioned things like soakaway drainage, but ground improvement options, if there are really poor quality areas of made ground, do the geotechnical engineers need to improve that ground in some way? There may be cut and fill balances, moving soils around the site ideally to avoid off-site disposal. And utilities, subsurface concrete, and creation of new pathways as part of the development with new utility corridors. Data gaps in site investigation, it's been mentioned to some extent, but quality of gas monitoring wells, is the sampling density sufficient? Can you phase and zone the site and look at doing more detail in some areas, the high risk areas, from a sensitivity perspective? And also just Olinka's slides, notice on one of the conditions it's quite common that it will say a site investigation is required prior to every phase of development, and it's quite important to understand whether that means that the council really wants a separate report, whether a site-wide report will be sufficient or not. If it is phased over years, which a lot of big development sites are, you might have done a PRA originally, but it might not be sufficient for the next phase, and you need to consider whether you need multiple reports. Other problems that you get, generic analytical suites from early stage investigations, asbestos data quality. If you want to do a good asbestos risk assessment, there's a high chance that an initial investigation won't have the right level of detail in your asbestos data, if you have it. And partial characterisation of linkages, which naturally comes out of a preliminary investigation. So there'll be a number of site-specific requirements, which are things that are really important for going into detailed in situ monitoring that we've heard, remediation that we've heard about. And river dilution, I know Teresa also mentioned, you've got to have a really good understanding of your site characterisation if you want to apply that. Main phases of risk assessment. I'm actually going to skip this slide. There's just too much complexity potentially in this DQRA for me to talk about now. But the main things that need to be covered: ground gas, which SOBRA covers, ground gas, control waters, human health, vapour intrusion, and all of those may be needed on a complex site. There are obviously others, property risk, water supply pipes, with more what you might consider generic approaches for assessment. So options appraisal, in the new LCRM guidance there is a worksheet which isn't online at the moment, but this is obviously quite a complex field of expertise, so it's should be supplemented by other guidance and specialists. Timeframes again, is there a need for feasibility studies and pilot trials, and some detailed criteria to assess remediation options, cost being one, but then the effectiveness, the timeframe, the durability, practicability, health and safety, stakeholder acceptability, sustainability and social impact. Again, this really is, so the remediation strategy, one of the really important things is it's not just about some numbers that come out of a DQRA, choosing a technique from an options appraisal and writing that up technically. It's a lot more diverse. You need to consider the permits and licenses needed, environmental management and monitoring, maybe actually separate planning conditions for things like nuisance, odour, dust, noise. The phasing of the works you need to take into account. You need a proper schedule of works. Practicalities, how are you going to do it? Are there restrictions on vehicle movements, maybe near schools? Other disciplines, geotechnical, ecology, invasive species, tree preservation orders, the seasonal restrictions from birds, bats, that kind of thing. And just another point, you can go through all of your DQRA and site investigation and develop your criteria, and then actually a large part of a remediation strategy might be bringing soils onto site. It's really important that you cover the control of bringing those soils on, which have nothing to do with what was on the site before, but it's really important to control, and that needs to come through in the remediation strategy as well, maybe through the definition of waste code of practice and a materials management plan with the and validation criteria. But again, that isn't the consultant's ultimate goal, the developer's ultimate goal. They're looking for that to be able to put into to be delivered feasibly, and so it needs to be able to be transferred into the next stage for a contractor. So maybe it needs to be able to be written up as a specification for tender documents. I think, summary that, one of the things that I was talking about, the word that I didn't manage to get on here, but I should have done and wanted to, is communication. In a big development of a site like that, there are an awful lot of disciplines involved. Contaminated land may seem like a big part of it to us, but it is an equal or sometimes very small part of it to a lot of other people. So communication is really important. I was talking to a client and trying to get his view on how he likes to keep that communication going. So obviously with ACOM, we have a lot of different departments. In theory, we can deliver a number of these different disciplines. And I was interested to know, is that how they like to work, or do they like to keep the communication in-house and use lots of different consultants for different things? And I think the view is that it really depends on the individuals. If they know and they can trust that they've got an individual in an organisation that can communicate all these complex disciplines well, then they might hand it out. But often they like to keep that communication aspect in-house, and so that's why you will get lots of different organisations delivering a big development, because they, in theory, trust themselves to communicate between the different disciplines. I think I'll leave it at that, because I've probably talked for too long. Thank you.
Whilst Teresa's loading, we thought it would be useful to have a little section on the the developer's point of view. I'm not a developer, so if they're already in the room, I'm really keen to hear what I've said wrong after the talk. But one of the common themes when we were planning this was that actually, even if the pre-planning, the discharge of conditions is absolutely a model process, sometimes when it actually comes to implementing remediation, it can just all fall apart. And so we wanted to add a little bit of insight and thought about actually some ways to maybe think about managing that process a little bit better. So we've got a few slides on remediation tendering. Thanks, Teresa. And I'm going to try and be really quick because I'm conscious we're running a little bit behind time. I think the key part for me in this stage is understanding actually how the remediation is going to be implemented and the verification. Is it going to be one contractor doing everything? That might be the case for a simple site. Or is it going to be lots of different contractors? Is one going to be doing the bulk dig, then you'll bring, which will include the hotspot removal, then another contractor dealing with the groundwater remediation? Is there going to be different phasing? Is the development a huge site which is going to be phased in different stages? Can one contractor do the entire thing, or is there going to be 7 or 8 different groundworks contractors? And don't forget the bits that come at the end, the gas protection measures, the soft landscape, often they're a different person. So you need to, the organisation needs to define, the developer needs to define who's doing what and make sure it's understood and documented somewhere. Also, who's going to be responsible for validating the remediation work? Is the entire package going to be given to the remediation contractor? Are they competent to validate it themselves? Are they going to have the sub-consultant that does the validation for them? On a complicated site, I'd always recommend that the developer retain some kind of third-party review, peer review of it, or potentially even full control of the validation. There's advantages and disadvantages to both approaches. But I think it's important to make sure there's some kind of technical oversight of what the remediation contractor's doing. Who's going to manage communications with the regulator? Does the developer just hand it over and say, contractor, just get my planning conditions discharged? Or will that be managed in-house? Once again, advantages and disadvantages, kind of risks and opportunities on both. Once again, I think for a difficult site, I usually generally recommend that the consultant looks after that, or at least has that involvement and can control that process. When you're preparing to tender, and I think a lot of this is all to do with the preparation, it's important to make sure that the requirements of the remediation contractor are really, really clearly defined. So it's not just sending them a remediation strategy and saying get on with it. There often needs to be more than that. There needs to be some really clear employees' requirements, explaining what needs to be delivered at the end of the process, especially as someone pointed out earlier, if it's a betterment style remediation. It's good to have all the requirements in one place. Sending out a pack of information and going, well, don't forget to refer to Chapter 8 of the SEMP and Chapter 3 of this document. It doesn't help when you're trying to keep on top of whether the contractor's meeting the requirements. Put it all in the same document. Also, how much flexibility is there for contractors to vary or propose a remediation approach? Once again, huge, there's different approaches of doing this. And often remediation contractors, especially the good specialists, can bring new things to the table, suggest new approaches, which can be really, really good for the project. But obviously there's the importance there of making sure that has been agreed with the regulator. So contractor selection, you need to make sure you've got a good contractor. Or at least if you've got a bad contractor, you've got control of them. But ideally a good contractor. Consider pre-qualification requirements. Have they actually got the relevant experience on similar scale and complexity of projects? When you're reviewing the responses, seek a specialist input. Listen to it. The amount of times I've kind of worked on the tender selection process and my least favourite contractor has got chosen because they're the only ones that offer the PI needed or the price or whatever. Has the contractor understood the scope of works? Once again, variations, make sure they're agreed, understood, appropriate, the regulators have approved them. Have they got the right resources? Once again, it's that contractor competency point of view. There's, consider scoring on quality versus price. Interviews, I think, are always really good. One of the really interesting sites I worked on, actually, the 3 top contractors, we were asked to go and, as a consultant on the developer's behalf, go and visit 3 remediation projects and see some of the documentation. So I think that was an example of really good practice. Getting started, remediation method statement. this explains how the contractor is going to implement the remediation strategy and the employer's requirements. Have they ticked all the boxes? Have they done everything? It's the first question. Secondly, is there enough time to get that reviewed by the right people, sending it to the regulator, especially if there are changes? And, you know, keep an eye on it through the project, things change. Contractor performance. Things can go wrong in remediation projects. Things can be not as expected. Are systems in place to monitor what the contractor's doing? You know, once again, that third-party review by a consultant of what the contractor's doing. And is there a system in place to make sure that if they do something wrong, it can be changed, that can be corrected? So maybe consider how the payments are structured. Now, this is where developers, it'd be great if someone could kind of chip in the Q&As, but, you know, maybe consider staging payments on provision of the validation information rather than just completion of the physical works. There's some ideas there. Just generally, I think the key point in this slide is just make sure it's understood how the work is going to interact with the other stages. And I think he will probably touch a little bit more on this on her next slides. But if there's lots of different stages of remediation or even lots of different stages of construction, make sure that different groups are talking to each other and the risks are understood and that measures are in place going forward to make sure residual contamination isn't forgotten about and is appropriately managed in the rest of the scheme.
Eve, do you want to come and introduce yourself? Introduce yourself.
Yes, I'm Eve White. I'm now with RSK, but I've been working with remediation contractors on site for quite a number of years. So just here to share some quick experience based, sort of scenarios to help, think about the next stage, actually implementing things on site. So we're going to start with
constructions.
Our scenario starts with a mobile treatment licence. Obviously, this needs to be deployed by the contractor, and that takes time. The information. There we go. Yeah, so the information that you will need as a contractor is obviously coming from our site characterisation information, and that's why it's so key to have that all the way along and all the changes that have occurred, because we don't see when the deployment form goes in exactly how the site is going to be remediated is what's going to have to happen. And if that's not what's going to happen, if the information is incorrect, things need to change, then obviously things need to be redeployed. And that's where you get the inconsistencies. If that isn't all fed back, and this all takes time to obviously be reviewed and approved, then the site's going to stall, and you get obviously very frustrated contractors, and you get very frustrated developers. So it's just a key thing, again, going back to that site data, and it's got to be site specific. These things can't be generic. You can't deploy that form and it just have the standard things written in it. It's got to have the key information for that site. As mentioned before, you've got to take into consideration the effect on neighbouring properties, who's next door, again, members of the public, anything interacting with that site. So we spoke about, again, important at the tender stage that it's understood that all this information does come across in a way that can be found and interpreted and taken forward by the proposed contractor. Our scenario site is working next to the river, so obviously with that involved there's a permit going to be needed for that. Again, that takes time to obtain. It's obviously any activity within 8 metres of the riverbank, so, and if it's tidal it's 16 metres. So again, you've got to think about the floodplains. All this site characterisation data again has got to have taken that into account in the remediation that wants to take place on site. There are obviously standard rules, permits, there are also bespoke ones. Sites such as our scenario, we're going to need bespoke one. These take months to look at, because obviously it's got to go to all the different specialists to understand what's happening. Obviously, certain contractors don't get brought on board until later on. Again, communication, different parties are involved, and all of this we find obviously doesn't make for a very smooth phase at this stage of the process. Then we've got time to reuse, actually say the treatment of soils has taken place and they can be reused on the site. Or to do that, obviously, before anything gets dug up, moved around, there's got to be the clear code of practice put into place if that's the scheme that's going to be gone under, or an exemption if it's going to be under the waste side of things. Or again, if people really want a permit to use waste on the site, then again, that's another different process. So all this has to be thought about, and the response, obviously, to any objections to the reuse has to be checked under the materials management plan, under the clear code of practice. So there's time for that to have to happen. Again, all the mass loss, depending on what the treatment system is, any additional mass, depending on, again, what the treatment process might be. The criteria, again, has all got to be explained in this materials management plan before it gets approved by a qualified person that obviously gets declared onto the website. So again, it's all a timely process. It's all got to be done by competent people, and the screening levels that obviously get used earlier on in a generic discussion are not suitable now for our site-specific reuse. So what's been found before is that these are not generic things. Again, they are site-specific, and if the information, the site characterisation hasn't been done to that level of detail, then how can you get to this stage when you would like to submit the information as a contractor to reuse soils? If it's not sufficient, then it's not going to be approved and the works can't go ahead. These materials management plans obviously talk about out of specification material, what will happen to that. Again, if there's going to be a variation in the treatment process, then there's a knock-on effect. Was it in the mobile treatment licence? All of these changes, again, have to go back up and down the line to be approved, and this is the time it takes. So it's just considering cumulative effects of that. And then all this information that's planned to happen is what's feeding into this validation report for this final sign-off and discharge of this planning condition. And then we've got the waste side of things. Obviously, sometimes there just isn't capacity to reuse. There's the treatment, obviously, process only works for a certain amount. Maybe that was all that was intended to be achieved. So the residues have got to go away. That's different data. That's different information. That's more testing. So again, time for that, making sure a competent person is actually testing that again. And are they testing for the right things again? Obviously, treatment has happened. It's changed. Then from that information has to go to the intended receiving facilities. They need to assess it. They've got to actually, approve it, accept it, before any waste can be moved anywhere. So all of that, again, time to check that, so the hauliers involved aren't usually a remediation contractor. They are getting that in as a subcontractor. So all that information, that duty of care, their permits, their waste carriers licences, where all this is going, all that documentation needs to go up to everybody in the chain involved in the site. So it is paperwork, it should be there, it should be standard, but it isn't always. And matching, obviously, duty of care documentation for obviously the hazardous waste consignment notes, all signed off, absolutely everything, copies of those, not just the site copies for collecting that waste. It's got to be fed back and obviously into that validation report for it to be valid. That's the only way to know that the waste has actually gone there. Was it non-hazardous waste that left the site, in which case, again, the waste transfer notes all fully signed, and then the tickets, the conveyance notes, having a matching tip receipt to make sure, again, that the waste actually was received there. All that documentation, that's timed records, so it's like a courier service. You need to know exactly where that lorry went, and it's important, for everybody's on the hook for knowing where that goes. So it's not just the groundworks contractor, it goes all the way up to the developer. So everybody's got to have all the paperwork, and then at the end of the day, that's the important part again, to know where all the soils went. So the validation report, go back to our materials management plan for reuse. Again, that's got to have the information tracking all of those soil movements on the site. Large phased sites, again, are going to need quite complex management. So it's basically an idea of consistency, having all the complete information, sufficient time to do it, and obviously, enough in the budget. Has it been actually thought about? All these deployments, they cost money to be assessed again. If there are any changes. Again, the treatment methods in the example before, luckily there wasn't so much of an increase in cost to change the method, but it can happen. And when you get disparities between the tendering process that was spoken about and, didn't perhaps have an allowance for this, then the contractors can get pressurised into wanting to cut corners. And then that obviously causes a lot of difficulties when it comes to actually enforcing the regulation. So there can be data missing, and that validation report won't actually achieve what it's meant to. Thank you.
You'll be pleased to know we're going to wrap this up with some verification snagging by Matt. Just have to find it first. Okay. Thank you for everyone who has come and stayed. For those who are leaving, who have to go, thank you for coming, and hope to see you again.
Right, before I worked for the NHBC, I spent 6 years as a remediation contractor. Before that, I was an environmental consultant. So I've done a bit of everything, and I'm very familiar with remediating big sites. And if you're working on that site all the time, you know everything there is to know about that site. You know, inside out, backwards, upside down, which is great. But then you've got to communicate to the regulators and tell them why you've done a good job, and so everyone can read the verification reports and be happy that you're clear that you have done a good job. Everything you've done, needs to be done, has been done. Everything's been finished, and everyone can get on and finish developing the site for whatever purposes. So I've just broken it down into maybe enabling construction phase, the actual sort of big, proper remediation works, earthworks kind of thing. Sometimes, the proper work, and then the that post-remediation stuff, the protection measures like gas protection and clean cover systems, which I see rather a lot of, and I see a lot of it done badly. So it's a bit of a brain dump all around, really, this is. So common issues. Again, it's all about, do we understand the site? So information that comes to me or doesn't come to me, we're often missing site investigation reports, supporting information, that background information that helps you understand the site conceptually. And if we haven't got that, then we can't really be sure that the remediation has been done properly. Then the remediation strategy, and the Regenesis presentation earlier was brilliant, because things change. You might start off with the site investigation doing one thing, but you get to site, it's a bit different. You do some more site investigation, you dig some more trial holes, you might dig it the entire site. And conditions change, things change, and that's fine. But have the Environmental Agency, the Council, the NHBC been told about it? Has everything been agreed? What's happened? Again, unexpected contamination, I probably should put unexpected conditions, because ground conditions could be different to what was expected. And all these things can just change the outcomes of the remediation and what's needed. And there's nothing more infuriating than you've read a remediation strategy, then a year or so down the line, you get the verification report, and it starts talking about a tank, And you go, hang on a minute, there's no tank mentioned in this. It's in this remediation strategy. Where's that come from? What was done? And invariably, it's been done okay. The information there somewhere, but we've not been given it. So that's just more time wasted, more to us going backwards, saying we're not claiming that condition until you tell us what's been done. Other issues, materials management and tracking. Again, on a big site, where's that remediation soil gone? Where's that asbestos contaminated soil been buried? Are you sure it's in the right place? And ultimately, if you set remedial targets and aims, whether it be betterment or whatever, has that been met? Have you got sufficient data, monitoring lines of evidence to confirm that's been done? Obviously, you'd hope there would be. And then you get the reports. On big sites, there's a huge amount of data. You can get masses of waste transfer tickets, monitoring data, analysis data. I know this stuff's got to be reported, but sometimes it can be really hard to follow. If that's been dumped on you from great height, 500 pages, and you read through the report, it says, right, sort of, this specific analysis certificate gives the details of what was the verification in this part of the site, and you can spend a long time trying to find that information. It's not an easy thing to report when you provide, but just try and make it as easy as possible for the reviewers to clearly set out the information. Just tell the story and just make sure it's easy to understand. If you've got a phase site, obviously make sure that you've got the information lined up for all the phases and all the verification, so that there's not something left in the corner that's been forgotten about. And then you can't have people start building houses and you think, and someone asks and says, hang on a minute, what about that hotspot in the corner? And it may have been done, but if you just make sure you get all the information to us. Don't forget the conceptual site model. So things change. If you dug up the entire site, put it down, move things around, things are going to be different. Has the conceptual model changed at all? Have you got rid of all those pollutant linkages? And obviously, and another bugbear of mine is if you, as a contractor, you present your remediator site to the developer. It's got sort of some contaminated soils buried at depth, 300 mil of maybe sort of 6F2 cover. And then, but how's that site going to be managed during the construction phase? Have you got sort of have you communicated the risks to the developers? What about the subcontractors? The amount of times you see sort of your carefully placed hard to dig layer being dug up by the drains and sewers not being put out properly, or one of my sites being robbed and the hardcore being used somewhere else. It's a key thing, and all of a sudden that remediation, that verification report, which might have been right, might no longer be right. There might be sort of materials at the surface which are still hazardous. So that just all needs considering. So then moving on to assuming everyone's happy with the site, it's all been remediated, but there's some protection measures still required, like gas. I think the one thing we just need to see that information beforehand and up to date. Tell us what you're going to do when. And the one thing I will say is just gas protection measures, especially for VOCs, aren't just a get out of jail free card. You can't just say you've got some VOCs and you can't say, we're just going to risk it away with some gas protection measures. It's not really best practice. But anyway, we need to see details of what's going to be done and when and how. And we need to see the membrane spec and understand that membrane and it's going to be suitable for its purposes. And we need to see a verification plan in the Series C735. We hardly ever see verification plans for gas protection measures, and it's a critical part of the process of getting everything signed off. So then what happens? Well, we get some reports in, different membranes being used, might not be suitable. The membrane's not been installed by an appropriately qualified person. That's not to say that, experienced person, because you get some subcontractors who aren't qualified to do an excellent job. But again, it's just documenting that's been used. And then it's asking if you need verification, where is it? What's the frequency? Again, which all should have been agreed in the verification plan. But we're often found just chasing that information and it's making that call of whether it's an issue. And ultimately, as we said before, if we're not happy, we're going to ask more questions and try and get more information, and those conditions aren't going to get clear for those plots. Then on to clean cover. It should be easy, but it's amazing how people can get it wrong sometimes. Again, that verification plan, where is it? Have you agreed the sampling ratio? How often are you going to go and sample the that clear people's back gardens? Is it every plot, every 4 plots? Just that needs to be agreed up front. And the clean cover source, where's that topsoil, subsoil, and all the hard to dig layer, the 6F2, coming from? Is it from a sort of a commercial supplier, so like British Sugar, or is it from another development site? If it's from a development site, is that sort of material suitable for use? Has it all been covered by Clare and the MMP? Do we know it's greenfield? It's all, and then the analysis results. You won't believe how many incorrect sets of chemical analysis we receive for a clean cover. What we need to see is obviously, is it compliant with the BS 3882, the British Standard for Topsoil? We also need to see all the your typical chemical analysis for where contaminants are concerned. But WAC testing is not acceptable, as I'm sure I don't need to tell anyone here, but we see it all the time. And is the testing that you've been provided, is that relevant? Is it, if you've got a commercial source and you've got some analysis from 2 years ago, is that really representative of the stuff that's coming onto site? Then that's actually not poor quality photos. Again, that's not a bad photo, but we see some rubbish. I do know it's hard sometimes when it's raining, it's muddy to take a decent photo, but it's not that hard. Then what happens when the concentrations are exceeded? If you've gone to test it, the lab results haven't come quite back as you expected. It might be all right, but again, just talk to us, talk to the people, talk to the regulators, and that will sort it out. Then, have you achieved the right depth? And missing geotextiles. If the spec says, or the remediation strategy says we're going to put in the geotextile marker layer, where is it? Hasn't been verified. Again, it gets forgotten quite a lot. And then obviously submitting reports at the last minute, it just makes everyone's life harder. It's not always easy to get things done on a site. You know, there's pressures, but the sooner you can get the information to us, the sooner the longer people got to review it, and the less issues you'd like to have. So key points. Basically, agree your remediation strategy and the verification plan with the relevant regulators, and do what you said and when you're going to do it. But if anything changes, keep the regulators and everyone else informed. Tell us if things have changed. I think most people want to help. Be clear and concise. Make it easy for us to review the information. Yeah, and just don't leave things to the last minute. Thank you.
Thank you very much for staying and listening through all of that. There's a lot of stuff to take in. So I'm going to come round and somebody else can take a microphone as well. If anyone's got any questions, if the rest of the tag team want to come up and field the questions, that would be great. Go on then, who's got a question?
Ali Thomas, Environment Agency. My question's to NHBC. How much stock do you put in NQMS?
I think at NHBC we support everything to improve standards, but we have our own standards, so it's not something I don't think we're looking and relying on at the moment. It's certainly I think it's been asked the question of us before, and we're aware it's there. We potentially support it, but we're not going to be actively involved in sort of pursuing it because we have our own standards and way of doing things.
Any other questions? Oh.
Hi, Chris Kitley from Tideway. It's just a comment, observation, question kind of thing as well. It's just you've obviously used a really good example of a large brownfield site and given us examples about all the good practice and things to do. I know that there's going to be a lot of pressure for more housing development in the UK, and especially in the southeast, and a lot of the sites might not be these huge mega brownfield sites. I just wonder if there's any comments on how we manage slightly smaller sites where the developers won't have such a large budget and the regulators might be asking for lots of information per se. Is there any
thoughts or discussions about how you might manage on a slightly smaller site, where a developer might have different pressures or anything?
I can try and have a go at answering that. I think the general principles is in the different stages, the following, sorry, microphones. In the general principles, the different stages, preliminary risk assessment, site investigation, remediation strategy if required. They're not often not. Some smaller sites might be more straightforward. They all apply. So does the CSM. So I think it's just taking that down and making it more simple. And I think doing things properly at the first stage actually can mean that the subsequent stages can be quite straightforward and hopefully things ruled out because they don't apply. You can get small sites that are very, very complicated, but you can get small sites, as you say, that are very straightforward, minor brownfield use. Maybe it was kind of, a garage or something before with no filling stations, in which case, hopefully it's just more straightforward to get through. But I don't think the principles change much. Anyone disagree? Or?
No, I was going to say, obviously, risk assessment, that's the whole idea, is that you do rule things out if they're not applicable. It's risk-based. But then there's cost savings to be had on planning like the waste in advance, designing so you don't have any. That's usually a very large major development cost. And having these specific criteria to try and keep the soils on the site. I've experienced before, usually the treatment processes far outweigh the cost of actually taking away hazardous waste. So it's usually worth investing in this investigation and site characterisation stage to save that money later on. Again, redesigning so that it can be, the more hazardous properties that would have been in the waste are now actually acceptable to remain on site, don't pose a risk to the future users or the environment, maybe under the parking areas, but parking areas tend to be, and roads tend to be sort of less voluminous than they used to be. So there's a lot of building footprints, and again, then you're into managing, yes, you can remediate to a certain level, great, keep it on site, you don't get the waste costs, but then you've got your gas protection measure levels have gone up because there's a vapour risk. So cost-benefit analysis and looking into all the options, spending the money that way hopefully saves money down the line and time with any costly processes.
Well, just from my point of view, I guess the problem with the smaller sites, if it's a small developer and they're less aware of contaminated land as an issue, and there tends to be, some would say, the people who employ the slightly cheaper consultants, and that can cause problems. But it's just finding ways of managing and trying to help them through that is tricky. Ultimately, you tend to sort of see a lot more sort of clean cover being proposed, whether it's needed or not, and the gas protection measures, whether needed or not, on the smaller sites, maybe less contaminated sites. I would also just a quick plug to, I think there's some Syria and NHBC guidance came out a couple of years back on contamination land risks for small sites, which is available on the NHBC Foundation website, I think. Is that right, Debbie? Yeah, I think it's free. So, and that's specifically aimed at sort of smaller sites. So it might be, if anyone's interested, it's there, it's free. It's quite a good read, relatively speaking.
Any other questions? As I said before, thank you very much for coming. Okay, so we've managed to secure coming to Geological this year, and I think the invitation to come back this time next year has also been extended. So we're hoping to be here again this time next year. However, I'm looking into options into doing one in September this year. Can I have a show of hands who'd be interested in like a Part 2A based discussion? Oh, good. It's worth running. So if you could, if you work somewhere where you could hold a meeting for 30, 40 people and happy to host a CliffNet event, could you email me separately to let me know? Also, if you're able to sponsor the refreshments as well, email me separately to let me know. Would welcome any feedback about today. I'm really sorry it's overrun today, but it was, I think where we are, in the industry, I think it was worth airing what we've aired today, if that makes sense. So thank you very much for your patience and sitting through all we've presented today. So if there's nothing else, thank you very much for coming. Give yourself a round of applause for being able to bear through all today, and safe journey onwards. Thank you very much.